In section 4.9, we're looking at similar triangles with parallel lines. Okay, so remember the arrows show us the parallel lines inside this triangle. You know we're doing similar triangles, so I hope in that picture you actually see two triangles, and I'll try to map those out for you. So first of all, the first one, if I was to draw these separately, remember they're similar, so they're not exactly like each other. You see this smaller one that's at the top, and then those angles, if I were to just draw these, would be CB and D. And if I were to draw the larger triangle that it's similar to, it would be C, lower left corner would be A, lower right corner would be E. Okay, now what I want us to do, just to make it easier again for us to communicate, is here's how you should always start. Eventually, I don't want you to have to draw the two triangles. I want you to be able to do everything in this picture right here. Okay, but let's talk about this. Notice angle C is in both of these. I want you to put 2 marks indicating it's in both pictures, which means that's the same thing you should be able to visually do without drawing it over here. Okay, so we'll just put that this is in both triangles. And since it's in 2 triangles, that's the only reason I go ahead and put 2 marks. Okay, it's not that it's right or wrong. This is what I'm going to be consistently doing. Likewise, because of these parallel lines. Okay, so that's a good review for final that's coming up somewhat soon. If I've got parallel lines, guys, don't forget, I see a couple of upside down, forward, and backward Fs, okay, here. You should agree that these 2 angles are corresponding. Okay, if you mark those the same and you come over here and do it in the picture, that would say this one and this one are also equal. Okay, likewise, because of the parallel lines, doesn't matter. You could have gone and said, oh, well, this one, I'll give it a different symbol because they're not equal to the other ones. That angle and that angle are also corresponding, which means over here in this picture, this angle and this angle are equal. Okay, so I'll give them the same symbols. So now, you've done this enough in this chapter. If you go based on the 2 triangles that we drew ourselves separately, and I asked you to map those triangles in the correct order, don't forget, for ease, we're going to make the first triangle, which is to me always the one on the left or the one on the top. That's the first triangle. We're making it alphabetical. Okay, so the first one would be BCD. Is similar to triangle. Now match the symbols. It would be ACE. So keep in mind that similarity statement should be the key to everything you do, okay, from here on out. So let's practice. Remember, we're going to try to avoid drawing the 2 triangles and just do the work in this picture itself, okay, but that's the visual of what's happening on the right. Okay, so you definitely need to start by doing some markings in each picture. So let's write down our directions for ourselves, okay, of what we will do. So this is going to say, set up proportions. And solve for X and or Y. Okay, whatever they're asking for. All right, so here we go. First things first. Let's do a lot of kind of reviewing as we're going through this together. So first in this one, I'm looking at this as 2 triangles. Again, I'm hoping you're seeing it as this top triangle and as the big triangle. Those are the only 2 triangles that I see, okay, with the parallel lines. So I'm going to get rid of that. Notice if you highlighted what we had in purple and red, the angle that's in both of them, if you just name them like OEM and OGT, O is in both. So that's why it gets 2 marks. Based on the parallel lines, right, because of those arrows, I'm going to mark these 2 angles equal because they're corresponding. Now, I only need that many. I don't care if you decided you wanted to put these in, okay, those two angles, but I'm going to prove to you in a second that I don't need that many, okay? And that's because of the old stuff and what you know. So I'm going to ask you, are these similar triangles? That's a question. If you were thinking about drawing them separately, are they similar? And you should be telling me yes by angle, angle. Notice, you've marked 2 sets of angles. That's all you need to prove, okay? You don't need all 3. So go ahead and mapping them together then. Triangle, remember the top one or the one that's to the left the most is what I consider the first triangle. That one should be alphabetical just to make it easier for us to talk. So I would have EMO is similar to triangle, matching the symbols would be GTO. All right, setting up proportions, this is what we're talking about. Side EM goes over GT because they're the first 2 letters. MO goes over TO. And the first and third letter go over the first and third letter. EO over GO. Okay, fill in the appropriate sides. Now notice EM is X, GT is 12, MO is 6, TO is, all right, well, let's look at this. Let's actually go over here and ask you GO. This is easier. If I ask you to find this length first, I know you're going to tell me 6. What did you do? You did 2 plus 4, which is the same thing you should do over here. The length of TO would be y plus 1 plus 6. And if you combine like terms, you would get y plus 7. Okay. And then EO is 4, and GO we already did. We added the 2 and the 4 to get 6. There we are. Okay. I'm going to think smart, do some cross multiplication to solve for x and y. If I think of those as fractions 1, 2, and 3, I'm definitely going to put 1 that has only x with 3 that has only numbers. Up to you if you're reducing. Those numbers are not that big. Okay, the 4/6, I don't want to accidentally mess it up, but yes, you could make it 2/3. If we cross multiply, I'd have 6 times x, which is 6x, and 12 times 4, which is 48. Divide both sides by 6, and x will equal 8. Okay, I'll take the second fraction because it has the y in it that I need to solve, and I'm still going to use the third fraction because it's all numbers. Distribute the 4 to the y plus 7. Don't skip this step if you're going to mess it up. 6 times 6 is 36. So if you can distribute without writing that, and you can go to 4y plus 28 and get that right every time, then you can skip the step above. Okay. If you subtract 28, 4y will equal 8. Divide by 4, y equals 2. Now, just to throw it in there, we should start always thinking about, does this produce an answer that is something we would expect? Okay. In other words, when we plug things back in, do we actually still have triangles? So let's just go fill some things in. Remember, we just put them in parentheses. So x we solved was 8. Let's put that there. Y was 2. So 2 plus 1 would give me that this little part is 3. Okay, well, let's decide. Are these triangles with those lengths in the first place? Okay, are those triangles in the first place? Well, if they're similar, I really only have to look at one of them. So I'm going to look at that top triangle that has lengths of 4, 6, and 8. Good review for the final coming up soon enough. Any 2 sides have to add to be greater than the third. Remember, our shortcut is do the 2 smaller sides, 4 plus 6, add to be greater than the biggest side. And you should be telling me that, yeah, 10 is greater than 8. Okay. Likewise, if you did the big triangle, you would be telling me that one side of 6 plus the other side of 6 plus 3, so 9, has to be greater than 12. And yes, indeed, 15 is greater than 12. So that is a yes. Those are triangles. Okay. Sometimes they like to put those questions on standardized tests or something, say what's wrong with this. Those are the kind of things that you would be looking at. Okay. All right, let's go back. Practice with this one. Here's the first thing to practice and get down, and that's understanding what this is giving you. This right here is telling you from O to R, that whole length is 30. And this says from here to here only is Y. Well, let's make it a number, guys. Let's make this a 10. If you knew the whole length was 30 and the little piece was 10, wouldn't you tell me that the other little piece is from here to here 20? I think logically you would tell me that. Okay, how do you get the 20 is what I want to know though. So what you would do is the bigger number, the whole length of 30 minus the 10 would give you the 20. Okay, so that's using numbers. Now I'm going to change it on you because we have variables in there. All right, it's a Y, it's not a 10. So here we go once again. If the whole thing is 30 and the piece from here to here is Y, then the piece from O to P is 30 minus Y. Okay, ask me about that if that throws you off. Likewise, the very first thing you always do, think about the two triangles. The top one and the bigger one. The top one, ONP, and the bottom one, OMR. Notice O is in both of them. Okay. I think I'll just use some different colors for this one so we don't get them mixed up at the bottom. So that one's in both due to the parallel lines. Up to you if you're going to do the angles on the side that are corresponding on the left side or the right side. I'm just going with those two. And here we go. Start asking myself those questions. Are these similar triangles? And you should be saying yes. And if somebody says why or by what, your reason is angle, angle. Map them in the correct order. The top one alphabetically would be MNOP. So NOP is similar to triangle. Now match the symbols. MOR is the only order you can go in now. Do your proportions. NO over MO. OP over OR. NP over MR. See if you can fill in your lengths. NO is 6. MO. M to O would be 9 plus 6, so 15. OP is 30 minus Y. That's why we had to find that to begin with. OR. Oh, that's the marking. That was the 30. That was what that bracket was about. NP is 10. And MR is 2x plus 5. Okay, coming down where I have a little more room. Of course, I'm going to use the first fraction because it's all numbers. And I think I'm going to go ahead and put it with the third one first just to solve for x. Just because I like to solve for x first. No real reason. Go ahead and distribute. 6 to the 2x plus 5 would give you 12x plus 30. 15 times 10, 150. If we subtract 30 on both sides, 120. Divide by 12, x will be 10. Okay. Likewise, if I use the 6 and the 15, first fraction, along with the second fraction, since it has the y in it, distribute the 15 to the 30 minus y carefully. We will have 450 minus 15y equals 6 times 30 is 180. All right. Why did I subtract 180 from both sides to get 270? Add 15y to both sides to have positive 15y. When you divide by 15, y will be 18. Let's go back in our effort of trying to figure out if it's a triangle. Let's go back and fill in some of our numbers. Okay, so let's change colors if it makes it easier to see. So 2 times x plus 5 down here. 2 times 10 would be 20 plus 5. This length is 25. Y is 18. I'll just go ahead and put that in that section. 3 minus 18 would give you, this section is 12. And now we're ready to do our check again. Okay, if somebody was asking you to kind of keep track of this. And I do want you to keep practicing about this. I want to know, are these really triangles in the first place? Well, the top triangle is 6, 10, and 12. So is 6 plus 10 greater than 12? And yes, 16 is greater than 12. That's a check. The big triangle has sides of 15, 25, and 30. So is 15 plus 25 greater than 30? And yes, indeed, 40 is greater than 30. So yes, these are triangles. Everything makes sense to us. They were triangles in the first place. Okay. Now, the next thing we need to talk about is a mid-segment, also sometimes called a midline. Okay, so you'll hear both words, mid-segment or midline. So by definition, a mid-segment, this is just something you have to know for when it's useful in the problem, is that it bisects two sides. Bisects two sides. Remember, bisects means cut into two equal parts. And you also need to know it is parallel. So notice there's no arrows in this picture, but you're going to automatically know that it is parallel to the base of the large triangle. Okay, which will be useful for some of these things. Okay, some of the things that we're solving. So let's do a little manipulation in this. That means just by knowing that definition, guys, I consider this, I'll just extend it a little bit. I consider this a midline, and here's how I know. I look on the left side, the side that it intersects, and notice it cuts it into two equal parts. I look on the right side and I notice that it cuts it into two equal parts. Anytime that happens, that means automatically this thing that was in the middle, it wouldn't be extended, but I'm just doing that for emphasis, would be what's called a midline. Now, just so that we can come up with our different equation, let's just treat the length that I have in red as x. And if they're the same, they're both going to be x. Let's treat, which means if I ask you the length of the whole thing, right, the big side of the triangle, x plus x would be 2x. Likewise, on the right side, let's call what I have in blue y, which means the whole length for the big triangle, the big similar triangle, would be y plus y is 2y. All right, well then if this is a midline and we're calling it z, I would like to know what the length of the bottom would be. Well, these have to do with similar triangles, guys. And so if you were kind of going through your process of saying this big triangle and small triangle both share that angle, by the definition, I know that this midline is parallel to the base of the triangle, which means I now can also say, once again, for instance, that these two angles are corresponding and congruent. Okay. And I can now set up my proportion. I can say the top small triangle, x, to the left big triangle, 2x, equals the top right side of the small triangle, y, over the big right side of the big triangle, 2y, would equal the bottom side of the small triangle, which is z, over, and following the pattern, guys, what's it going to be? If it's x to 2x, y to 2y, it's going to be z to 2z. Okay, so this is 2 times z. So what you just came up with, guys, is the equation, which I'll just kind of put in words. You know that 2 times whatever the length of the midline or mid-segment is always equal to the base of the large triangle. Okay, so your biggest challenge first is to, one, not assume everything is a midline, and then, but look for that first, okay? Because this is a lot more simple than the other stuff that we're doing. So if I ask you to solve for x in this picture, my question to myself is always going to be, does this happen to be a midline? If no, go on and do similar triangle stuff that you've been doing. But since I see that that cuts this side in half and that side in half, I know it's a midline. So it's as simple as me saying, well, I know the equation is 2 times whatever the midline is, which is x, equals the base of the triangle, which is 12. That's 2x equals 12. Divide by 2, and x equals 6. Okay. On this problem on the right, again, I see 2 triangles. I see this smaller one, right? Just for visuals. And I see the bigger one. Again, I don't want to make too many assumptions. Okay. So the first thing I'll always look for now that I've learned it is it a midline? Well, the only line that could be possibly the midline is this one, right? Is it a midline? If it is not, go on and do your similar triangle stuff. If it is, use our equation. So is that cutting through this side? Those 2 marks are equal. Is it cutting through this side? Those 2 marks are equal. So most definitely this is a midline or a mid-segment, whatever you want to call it. So following the equation then is 2 times, I'll just put in parentheses, whatever the midline is, which is 5, equals the base of the triangle. Remember, it's whatever it's parallel to. So we're talking about that guy. Okay, so 2 times 5 equals 4x minus 2. Okay, so if 10 equals 4x minus 2, add 2 to both sides. 12 will equal 4x. If I divide by 4, x is 3. Okay, again, don't make too many assumptions that everything's a midline now that you've learned that, but do look for that first, okay, because that is a lot faster than having to do an entire similar triangle.